Hello, class. This will be the recorded lecture for section 6.5, which is continuation of logs. Now we're going to talk about log properties. Just like there were the law of exponents, there's the laws of logs. They call them properties of logs. A little bit easier to say, right? So we're going to talk about 5 different styles of properties. And there's 4 log properties. One of them super important. And then there is this change of base for logs. And so let's start with the change of base. In the grand scheme of things, the least important of all of them. But this is the idea of what happens if you are trying to solve a log function where you need to get some numbers and you can't plug it into your calculator. And so this is how you do what we call the change of base formula to actually use your calculator, because you couldn't just put the base of every single base on your calculator, right? And so this is how we do it. And so what goes on the top is log of the argument, and then what goes on the bottom is log of the base. And so the strategy is that you either use log base 10 for the log or natural log. I always use natural log. Personally, that's what we use mostly in the engineering world. But most students like base 10. So let me walk through a couple of these. So here's would be one example here. And I'm just going to use the slides for this. So here we have log of 5, argument 8. So here we use base 10, and what goes in the numerator is log of 8, and what goes in the denominator is log of 5, and you just get out your calculator and do the division. You could do the same thing with the natural log. That's what I do. My calculator, I know where that natural log button is, so it's easier for me. And so you could do the exact same idea. So we're not going to spend a lot of time on this. It's not, in the grand scheme of things, a very important application, but just in case you ever need to do that, that is called the change of base formula. What is more important is the other ideas or properties of logs. And there are 4 more that will I think 3 more maybe, I don't know. But there are some that we're going to walk through. And here we're going to spend more time on implementation of these types of properties. And the first one's the product rule. And remember, because they're inverses, they're going to have an analogous of an exponential law. And here's the idea here that when you have 2 bases and 2 exponents, right, and the bases are the same, you can add the exponents. So think about it in the inverse idea of using logs. Now, if we multiply the 2 arguments together, right, you can see how they're the same up here. You can split them up into a plus. And so that would be what we would call the product rule, excuse me. And so what I'm going to do here is try to keep these up here on our whiteboard, because we're going to be manipulating equations using this rule. So that would be log of base A of M plus log of base A of N. And then this is called the product rule. Okay, so when we take a look at this for an example, and this one's a weird one, right? But say like we had an example like this. Log of base 2 of P cubed and Q. And so you wanted to split it up into 2 separate logs. Well, if you think about it, the M value is P cubed, and the N value would be the Q. And so if we split that up, again, we have to have the same base. So that would be p cubed. And then we could do plus log of 2 of q. And remember, you can go both ways, which makes it kind of interesting with regard to that. So say like we had this function. Say like we had log of x squared plus log of y. And I said, put that together. So now we can go the other way, right? Where if you look over there, we could define m as x squared and n as y, and you could put those together and it would be log of x squared times y. So again, you can go both directions, and depending on what you're trying to do, sometimes it's good to go one way, sometimes it's good to go the other way. Usually, when you're solving equations, this is the way you end up going, is that what you're trying to do is to combine all these logs into one big log function. And then sometimes we just convert it to an exponential. And there's other techniques. We're going to do that actually in the next section. So this is the product rule. So I paused it there to erase the board and get to the next slide. And so the next rule we're going to talk about is the quotient rule. And very similar to the product rule, except now we have a division inside the argument of the log instead of a multiplication. And just like in the law of exponents, when we have same base and we divide, we could subtract the exponents. Same thing with this idea. We could subtract these, split the logs into two, and put a subtraction in the middle of that. And so let's walk through a couple of these examples. And so here is the product rule. And so this idea would be, let's find one here. Let's start with something like this. Say like we had log of base 4 in this case. Say like we had 8 divided by w. And so to split that one up, since we could think about the m value being 8 and the n value here being rw. And if we split that up, it'd be log of base 4 of 8 minus log of base 4 of the letter w. Let's do one with numbers. Say like we had this one. Say like you had a problem like this. Log of base 2 of 64 minus log of base 2 of 16. So now we can go the other way. So now we can combine them. So you could see that in this case, the m value would be 64 and our n value would be 16. I did forget to mention, but we do know that the denominator can never be 0, so by definition. And so when you do this, we combine them, and that would be log of 2 of 64 divided by 16. And so that would be log of base 2 of 4. So can we solve this? Well, the answer is going to be 2, but just to refresh everybody's memory, let's do the conversion. And so if you do the conversion, it would be 4 equals 2y, right? And so that would be 2y, whoops. I never hit that erase button, right? I always have to hit it a little harder. So that 4 is 2 squared equals 2y. And so that implies y equals 2. So you can see that we're going to be using these types of techniques to solve log functions. So I think this is a good place to stop this lecture. I don't want it to get too long. And so we're going to introduce one more, probably the the power rule for logs, which is probably the rule that I've used the most in my engineering life. And then we'll introduce walking through some more of these examples using the properties of logs.